Here we have a more formal definition of a Venn diagram, which is a pictorial representation of sets as circles or closed curves. They can be blobs, they don't have to be circles, which is enclosed by a rectangle, and that rectangle represents U, the universal set. The common elements of the set of these sets are depicted by the overlap of the circles. Now, looking at the examples at the bottom, I have two very common Venn diagrams, one for 2 sets and one for 3 sets. You've seen these before, and we'll talk more about what these regions represent in just a little bit. You can see here that Venn diagrams are meant to and do represent all of the following relationships. So for any 2 sets inside your Venn diagram, in other words, for any 2 circles, okay, you're going to have A union B. The intersection of any 2 sets is also a region in the Venn diagram. So every intersection of sets must be depicted in its own region in a Venn diagram. The complement of any set, and the difference is also in there, either A minus B or B minus A for any 2 sets A and B. And as such, Venn diagrams are a useful tool in helping determine the number of elements in a given set relation. As you probably already have some experience with Venn diagrams, you might know what I'm talking about. Sometimes when I am doing a problem that involves a Venn diagram or that involves counting the number of elements in a set, I just label the regions the way I do here. I use Roman numerals. It obviously makes no difference. You don't want to label them with A and B because you're already using A and B to represent the sets. But you can see here that there are 4 regions, and I have a couple of relationships over here on the right. For example, if you take region Roman numeral 1, union it with 3, you get the set A. 2 and 3 is the set B. All 3 together is the union of A and B. You probably understand the rest of them, but 3 is the intersection and so on. You should look at these and just make sure that you understand the correspondence between the regions and what they're equal to. Just as an example, I want to show how you can inspect a Venn diagram to recognize set identity. Now, I just chose randomly some set identity that A intersect B is equal to A union B minus the union of A minus B and B minus A. Now that's pretty confusing when you see all those letters just standing out there, and you might not be able to make heads or tails of it. But if you do this in terms of Venn diagrams, it might be really much easier to see what I'm talking about here. Now, on the left side of the equal sign, we just have A intersect B, the region in the middle. Now, on the right-hand side, we have A union B, which is in blue over here. And then what I'm going to do is show the union of A minus B and B minus A. I do that by first splitting it up into A minus B, which is the moon on the left, B minus A, which is the moon on the right, so that their union is the yellow, both the left and right moons. So you can see that if I take A union B and I subtract out the left and right moons, what I'm left with is the middle portion, which is the intersection of A and B. And that's just one way you can use Venn diagrams to make your life easier when determining whether sets are equal. Here's your typical Venn diagram that represents 3 sets, which I've called A, B, and C. I color-coded it and got a little excited about learning the stamp feature on my Zoom whiteboard. So I used the stars to represent the complement of the union of the 3 sets. That's the bottom one. Now, every other set, the red set, all the way to the left is A minus B minus C. The blue is B minus A minus C, and so on. Check to make sure that you understand what each of these regions represents. Now, just as a caveat, this is not the only way that you can write out the names of these sets. For example, there are other ways to write out A minus B minus C. If we can find an identity where another set is equal to the same region in the Venn diagram as A minus B minus C, we might represent it that way. Let's show what I'm talking about. You can see as my first example, I rewrote A minus B minus C as A intersect B complement intersect C complement. They're the same set. For now, you can just look at the Venn diagrams and either by intuition, by writing it out with pictures the way I did previously, you can see that these 2 sets are the same. Another example would simply be saying that A union B complement is the same as A complement intersect B complement. And see you on the next video.